If you're looking for a quick Python project that you can use to practice your skills and learn about some new Python features, then this video is for you. What we're going to do here is build the popular game known as Mastermind. This takes about 75 lines of code. I'd rank it kind of intermediate difficulty, and it's going to teach you a lot about Python, especially if you're kind of a beginner or getting into those intermediate stages. I'm also going to show you how to properly lay out a program. Even though this is small, you're going to see how an experienced programmer names their variables, creates the different functions, and kind of just sets up the general structure of the program, which is some valuable information. So with that said, let me give you a quick demo of the game so you understand how it works, and then we'll get into building the project. All right, so I've got VS Code open here. This is where I'm going to run and write all of the code for this project. If you don't already have it, I'd recommend you download it from the link in the description. Regardless, you can still use the Python IDLE or whatever your preferred environment is. This is just what I'm using for this video. Now, I've already written the project just so I can demo it for you. So let's have a quick look at how it works. So this game is Mastermind. The general idea is you're going to have a player, in this case, that's going to be us, who has to guess a 4-color or kind of 4-digit code. So in this case, the computer is going to be the one generating the code. Typically, you play with 2 people and one person is kind of the code maker. Okay, so I've actually printed out what the code is here just so that we can see it and kind of compare to it as we go through this demo. Typically, you wouldn't show the user what the code is. So it says, welcome to Mastermind. Attempt to guess the 4-digit code. You have 10 tries. The colors that can make up the code are red, green, blue, yellow, white, and orange. So you're going to make a guess of 4 colors. Try to guess what the code is. I always like to start with just one color, so red, 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 red. Okay, so now we can see that we have 0 colors that are in the correct position and 0 colors that are in the code that are in the incorrect position. So now I'm going to go with, say, white, 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 white. Okay, 0 again. Now, obviously, we can see the code, so let's speed this up and go with 4 yellows. Now it tells me that I have 2 colors here that are in the correct position and 0 that are in the incorrect position. That's because these 2 Ys are in the correct position. If there was another Y, but I didn't have it in the correct position, then this would give me a 1. Okay, so now we have Y, 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 Y. So let's do G, G, Y, Y. Now it tells me I have 3 in the correct position, but I don't know which those are necessarily. So I'm going to go with maybe W. Actually, not W. Let's go with like O. Actually, G, O, Y, Y. Okay, and now it tells me I have 2 in the correct position, 1 in the incorrect position. The reason I'm getting incorrect is because I have a green here, so I've put that there. It's in the code, but it's in the incorrect position. So hopefully that makes sense. That's why it's showing it to me. And now we can just go ahead and guess the code. All right, and there we go. We guessed the code in 6 tries. There you go. That is the Mastermind game. It'll make more sense as we go through the tutorial. With that said, let's dive into the project after a quick word from our sponsor. Thanks to Contrast Security for sponsoring this video. Contrast Security provides a world-leading code security platform that is purposely built for developers to get secure code moving swiftly. Contrast also makes security testing available to all developers for free with their CodeSec. CodeSec is the fastest and most accurate scanner and can be up and running in less than 5 minutes. With CodeSec, you can scan, secure, and ship your code in minutes for free while finding 70% more critical vulnerabilities and actionable results with 6 times more true positives in just seconds. Start by installing Contrast, authenticate, and then with one command, audit your entire code base and get detailed information about security vulnerabilities in seconds for free. Get started with Contrast Security and start scanning your code with CodeSec today for free by clicking the link in the description. Thanks to Contrast Security for sponsoring this video. All right, so let's go ahead and start building this project. Now, I'm just going to spend a minute here and discuss what it is that we actually need in terms of the subcomponents for this project, that we can build those one at a time and then kind of tie them all together at the end. This is a good practice whenever you're writing code. You want to think about it for a second before you just dive into the code. So the first thing we need to do is we need to generate a random code. This is going to be 4 colors or 4 digits, whatever you want to refer to it as, and they have to use kind of the 6 colors that are part of the game. Okay, that's step 1, generate a code. Next, we need a way for a user to guess what the code is. And we want to make sure that what they're guessing is valid. So if they guess only 3 colors, or if they guess 5 colors, or if they guess a color that doesn't exist, we need to give them some feedback and tell them, hey, that's invalid, make another guess. Now, after that, we need to compare their guess to what the real code is. To do that, we need to determine the number of correct colors, the ones that are in the correct position, and the number of colors that are in the code that are in the incorrect position so we can give them that output. This is probably the most challenging part. Don't worry, I'll walk you through how we do that. After that, we kind of just need to tie the game together, right? We need to do 10 guesses. We need to constantly give the output saying, this is how many correct, this is how many are incorrect. We need to determine if the user got the correct code, and we need to determine if the user lost the game. That's really all we have to do. What I like to start doing is building out each of the individual components, and then at the end, I kind of tie them together. So let's go ahead and do that. Step one is going to be to generate our code. So since we're going to be generating a random code, I'm going to start by importing the random module. And now I'm going to define all of the colors that we're going to be using. So I'm going to say colors in all capitals. The reason I'm doing capitals is because this is a constant, and that's kind of a convention in Python. It's a variable that's not going to change. So for my colors, I'm just going to refer to my cheat sheet here for what we have. We have red, green, blue, yellow, white, and orange. I don't know if these are the real colors that are used in the game, but these are just the ones that we're going to use. And in the real game, it has 6 colors. That's why I'm doing 6. Okay, next, I'm just going to define a variable called tries. I like to put all my constants at the top of the program, just so they're easy to find, and this is the number of tries you get in the real game, so I'm doing kind of the same thing, 10 tries. Okay, next, we're going to write a function, which is going to generate the code for us. So I'm going to say define generate underscore code, like that. Now, I'm actually going to make another constant called code length and make that equal to 4, just because if I wanted to make this game harder, maybe I make the code length 5 and I increase the tries. You can kind of make this dynamic by changing these different values, assuming that we use them properly throughout the program. Okay, so for generating the code, we need to create, in this case, a list. The list is going to contain all of the elements in our code, and we're going to have 4 elements. So I'm going to say my code is equal to an empty list inside of my function. By the way, a function is just a reusable block of code that you can call multiple times. If you're unfamiliar with it, it's just something that we can use later on, so I wanted to mention that. Okay, now that we have our code list, we're going to insert 4 random colors into that list. To do that, I'm going to say 4 underscore in range, and then I'm going to go the range of my code underscore length. And this underscore is essentially a placeholder for what you would normally put here, which is like I or X or some value. In this case, I don't care about what iteration I'm on, so I can just put an underscore, meaning I don't really care about what that variable is. It's kind of like a placeholder. It's known as an anonymous variable. Okay, what I'm going to do now is select a random element from this colors list. The way that I do that is I say color is equal to random.choice and then of colors. Okay, that's going to randomly select a color from this colors list. I'm then going to say code.append, and then I'm going to append that color into my code. This for loop is going to run 4 times, which is our code length. It's going to randomly select 4 colors and then put that into our code. Okay, then I can return the code from this function, which is what I can access when I call this function. So the way this would work is I'd say code is equal to generate code. Then it's going to give me a list of 4 random colors. Perfect. Okay, now we have a way to generate the code. The next thing we need to do is allow the user to guess the code. So I'm going to make a function for that. I'm going to call this guess underscore code. All right, so for guessing the code, we're going to have to ask them to enter some input. So I'm going to say their guess is equal to input. This allows the user to type in the console, and I'm going to say guess colon like that. Now, what I'm going to do is convert their guess to all uppercases, just so that if they type like a lowercase g here, we're going to convert that to an uppercase g. So when we compare it to the real code, we don't get an issue if they typed in lowercase. Then what I'm going to do is use the .split function. Now, I'm going to put a space inside of here, and what this is going to do is it's going to take all of the input and turn it into a list based on all of the spaces. So for example, if I have GG like that, and I have spaces in between them, then what that .split function is going to do is use all of the spaces to create elements in a list. So I'm going to get a list that has 4 G's inside of it, and it's going to remove all of those spaces for me. Hopefully that makes a bit of sense, but it's just going to take all of the spaces and kind of grab all of my individual colors using the spaces as what's known as a delimiter. If you wanted to do it with commas, you change this to a comma, and then you would expect an input like this, if I could type that correctly. Okay, hopefully that makes a bit of sense, but that's what .split does. All right, now that we have a list containing all of the different colors the user inputted, we're going to check the length of that list and see if it's equal to 4. That will tell us if they inputted 4 colors or not. So I'm going to say if guess, or if the len of guess does not equal 4, then I am going to print you must guess 4 colors, okay? And really, rather than doing 4, I'm going to change this to be the code length so that later on, if we want, we can change what the code length is. And then here, I'm going to use an f string and do code length as well. An f string is available in Python 3.7 and above and allows you to embed variables directly inside of a string using curly braces. So you put an f before the string and then curly braces like this, and you can insert the variable directly in the string. Now, while I'm at this, I'm going to put all of this inside of a while loop, because if they input an invalid code, then I need them to go through the loop again and give me another guess. So here, inside of this if statement, I'm going to have a continue, and what continue will do is just bring me to the top of this loop. Okay, so if the length of the guess is not equal to the code length, we print this, and then they're going to have to guess again and keep doing that until they give us 4 digits. Lastly, I need to make sure all of the colors that they guess are actually in the colors list. So to do that, I'm going to say for color in guess, which is now a list, and I'm going to say if color not in colors, then what I'm going to do is say print another f string invalid color, and then we'll put what the color was, and we'll say try again. Okay, then what we can do is we can break out of this. Then what we can do is we can put an else statement here, and we can say break. Now I'm going to explain what this means, but here I'm just going to return my guess. Okay, I think that's all we need, but let's have a look at it. So essentially what I'm doing here is I'm looping through every single color in the user's guess, because now this is a list and it contains all of the individual colors that were separated by spaces. I'm going to say if any of the colors are not in this colors list, so that's all of the valid colors here, then I'm going to tell them, hey, this is invalid, please try again, and I'm going to break out of this for loop. Now, when I break out of this for loop, what that's going to do is essentially just make it so I continue with this while loop. Now, what this else statement does here is essentially check if I didn't break out of the for loop. So what I'm doing is I'm saying if I never encountered this break keyword inside of the for loop, this else statement is going to run. That means that all of the colors they had were inside of the colors list, because if this never happened and I never braked, that means every single color I had was valid. Okay? Now, that brings me into the else here because I didn't break. So that's what the else is doing, telling you if you didn't break out of the for loop. And then from this else, I'm breaking out of the while loop. So this is while true. So the only time I get out of this while loop is if I pass through this for loop and all of the colors are valid. Hopefully that makes sense, but this is what you can do on a for loop. It's actually really cool syntax, allows me to determine if I broke or not. I didn't break, so I'm going to break here out of the while loop and then return whatever the guess is that the user gave me. Okay, so that is guess code. Now that we have guess code, the next thing we're going to do is say check code. Okay, and here we're going to take the guess and the real underscore code, and we're going to check how many are correct. All right, so this is a little bit more complicated, and what this involves is essentially looking through every single color in our code, and first of all, determining if the guessing color matches the real code color. So that's the first thing that we need to do. That's the easy part. Now we can determine how many colors are in the correct position. Once we do that, though, the more difficult part is determining the colors that are in the code, but that are not in the correct position. The reason for that is that we could have colors that are in the correct position, and we don't want to count those as being in the code, but being in the incorrect position. Again, I know this seems a little bit weird, but there's a few things we have to do here. So just try to follow along with me and I'll explain it as we go kind of step by step. But step 1 is going to be check the correct position. Then we need to check the colors that are in the incorrect position. And it's important we do it in that order to make sure we don't double count a color. So what I'm going to do here is I'm going to say color underscore count, or counts, is equal to a dictionary. And then I'm going to say correct underscore pause is equal to 0. And incorrect underscore pause is equal to 0 to keep track of the colors in the correct position and the incorrect position. All right, first thing I'm going to do here is I'm going to say for color in the real underscore code, and I'm going to keep track of the counts of all of the colors. So I want to know, do I have 2 reds? Do I have 1 yellow? Do I have 1 green? I'm going to store that inside of the color counts dictionary. So I'm going to have something like green and then 2, which means we have 2 greens inside of the code. The reason I want that is so that later when I'm checking the incorrect colors, I can make sure that I'm not using colors that were in the correct position or counting those towards my incorrect. You'll see what I mean, but just try to follow along. All right, so I'm saying for color in real code, I'm going to say if the color is not in the color counts, which means the key, right? So like key meaning like this, green. And sorry, I need to get out of this. If the key is not inside of the dictionary, then I want to add it. So to add it, I'm going to say color underscore counts. And then this is going to be at color is equal to 0. And then no matter what, let me just close this. I'm going to say color counts at color plus equals 1. So again, I'm looping through all of the colors in my real code. I'm saying if this color is not a key in the dictionary, then we need to add it. So I'm setting that key to 0. The reason for that is that if I try to increment a key that doesn't exist, I'm going to get an error. So if the color is not there, I add it in. And then no matter what, I increment the count for that color in my dictionary. If you're unfamiliar with dictionaries, I have a ton of Python tutorials. I think I have one specifically on dictionaries. You can check that out from my channel. All right, so now that we have the counts, what I want to do is find all of the colors that are in the correct position. So I'm going to say for guess underscore color, real underscore color in, and then I'm going to use a fancy function called zip, and I'm going to zip the guess and the real code. Now, what this zip function does is the following. It's going to take my two arguments and it's going to combine them into tuples. So if I have guess and real code, let's say my guess is equal to like G and R, and my real is equal to like W and yellow, then what the zip is going to give me is the following. It's going to give me a list that has, if we could do this properly, has G and W and has R and Y. Okay, so it's going to essentially combine the elements at the same position into tuples and then give me a list of that. The reason for that, or the reason I'm doing that, is so I can easily compare them, because now I have a tuple, and then what I'm doing here is decomposing the tuple into its two individual elements. So I'm getting the real color, or sorry, the guess color, and then the real color, which are the two elements from my tuple. Hopefully that makes a bit of sense, but that's how the zip function works. So now that I have that, I can compare them. So I'm going to say if the guess color is equal to the real color, because again, these are at the same positions in our codes, then what I'm going to do is say my correct underscore positions plus equals 1, and I'm going to decrease the count from my color counts dictionary. So I'm going to say color counts at, and then we can use either the real color or the guess color because they're the same, it doesn't matter, at guess color minus equals 1. The reason I'm doing this is I want to mark that this color that I just found is in the correct position. So I don't want to potentially count that when I'm counting the colors that are in the incorrect position. So you'll see how it works when I start looking at the incorrect position, but I'm essentially getting rid of that color from the count to make sure that I don't use it again and count it as an incorrect color, because it's not incorrect, it's in the correct position. So now I need to kind of remove it and forget about it because I've already handled it. Okay, now we've done all of the correct colors. Pretty easy, straightforward with the for loop. Now we need to do the same thing, but for the incorrect colors. So again, I'm going to copy this kind of for loop structure. And now I'm going to say, if the guess underscore color is in the color underscore counts, I could use the real code or color counts. It doesn't matter. If I use color counts, it's checking if I have a key that exists in color counts. So it's the same thing. And color underscore counts at the guess underscore color is greater than 0. All right, sorry for the cut here, but I want to quickly demo to you an example of a real code versus our guess and what we would tell the user and kind of why we're writing the code the way we are. So here we have our real code, which is green, orange, orange, orange. And then we have our guess, which is green, green, W, W. In this case, what we tell the user is that they have one color in the correct position. That's it. They have 0 colors in the incorrect position. The reason for that is that the greens here are in the correct position. So that means if I see another green, I'm not going to say that's in the incorrect position because there's not another green in the code that it doesn't match with, right? Here we have these two greens. They kind of cancel each other out. And now as we go through the rest of the guess and we compare that to the real one, we don't say to the user, hey, this is in the incorrect position. We would only do that if there was another green in the code. So hopefully that makes a bit of sense. Now, the reason we're going through this whole process of keeping track of the count is so that as we go through here and we see this green, we make sure we don't tell the user it's in the incorrect position just because a green existed before it. This green, since it matched up with a green that was in the correct position, shouldn't be looked at anymore, hence why we're subtracting it from this color count. Hopefully that makes a little bit of sense, but that's why we're keeping track of the counts. And that's why we need to first go through and keep track or find all of the colors in the correct position. Then only after we do that and we determine how many other colors are left to kind of match up, we go through this. Okay, you can mess around with a few different examples and try kind of changing the code around and you'll see what I mean. But hopefully that gave you somewhat of an idea of why we're writing the code the way we are. Anyways, what I'm doing here is I'm saying if the guess color is in the color counts, so if the key exists and the key there is greater than 0, meaning we still have a color that we can use to kind of match with this one, then we're going to say the incorrect position plus equals 1. And again, we're going to subtract our color counts. So color counts at the guess underscore color minus equals 1, because now we found one color that's in the incorrect position. So we want to make sure that we're not going to say another one is in the incorrect position if there was only, say, one color to match with. So we need to, every time we tell the user one's in the correct position or in the incorrect position, kind of eliminate that color from the code to be matching against as we continue kind of doing this check and matching. All right. Now that we have this, we should know how many correct and incorrect positions there are. So we can return both of those pieces of information with correct pause, incorrect pause, separated by a comma. We can just get both those pieces of information out of the function. Okay, now we have the three main components of our game. We now need to link them together with some main kind of game logic. So I'm going to make another function called game. Inside of here, I'm going to start by generating the code. So I'm going to say the code is equal to generate code like that. All right, that gives us our code. Next, I'm going to have a for loop, and I'm going to say for actually attempts in range, and then this is going to be 1, comma, and then tries plus 1. Okay. The reason I'm doing this is because the range function will go up to but not include the last value here. So I'm going to just start at 1 and go to, in this case, 11, which means I'm going to go from 1 to 10 so that I have kind of the correct try number. Hopefully that makes a bit of sense, but you'll see why I'm doing that in a second. All right. Then the first thing we need to ask the user to do is guess the code. So I'm going to say guess is equal to guess underscore code. Very simple. You can see how our functions are helpful now. This is going to get the user's guess. Once we get the user's guess, we want to compare that to the code. So I'm going to say correct pause, incorrect pause is equal to, and then what do I call this? Check underscore code. We're going to pass the guess and the code. Then we need to tell the user some output. So we're going to say print f string, and we're going to say correct positions, and then this is going to be correct underscore pause. I'm going to do a pipe, and then I'm going to say incorrect positions, and then incorrect underscore pause. Okay, very good. And then it's going to ask them to guess again. So that's really all we need. Although I want to check if the user won or if they got the code. So actually, before I do this, I'm going to say if correct underscore positions is equal to the code underscore length, then I'm going to print you guessed the code in, and we'll do an f string here as well. And then this is going to be attempts and then tries like that. And then I'm going to break out of the for loop so I don't tell them this after I already told them that they guessed the code. All right, then we're going to have an else statement here, and I'm going to say print you ran out of tries, the code was, and then I'm going to do asterisk and then the code. Now what this will do is just print out every individual element from my list. So essentially what asterisk does is just takes every individual element and kind of passes it to the print function, which means the code is going to be printed space separated from this variable. You'll see what I mean if we actually encounter this case, but it's kind of a cool thing you can use to print out a list and have it look decent with kind of space separated values. All right, I think that's all we need. I'm just looking here and making sure this is okay. And yeah, I think that's it. Lastly, what we can do is just print kind of some intro text here. So we're going to say print, welcome to Mastermind. You have, and then this is going to be f string tries to guess the code, ... And then I'm going to say print, and then the valid colors are, and then again, asterisk, and then this time we're going to do colors. Okay. Lastly, we need to call this game function. So I'm going to say if __ name equals __ main, then game. This will run the game one time. If you wanted to run the game multiple times, you could put this inside of a while loop and then continue asking the user, do you want to play again? If they enter yes, you run the game again by calling the function. If they enter no, then you just quit and stop running the game. If you're wondering what this line is here, this just makes sure that we're actually directly running this Python file, because you can import Python files. And if you were to import this file without having this line, like let's say you just had game here, then it would run the game when maybe you don't want to do that. You just want to be using some of the functions that are inside of our code. So this just makes sure you're directly running the Python file. All right, I think that's going to be it for the game. I want to quickly run through the code, then we'll just make sure it's working. So let's go through this first. We're printing, our welcome messages. We generate the code, and then for the number of attempts that we have, we're going to do this. We say the guess is equal to guess code. Okay, that just gets the user to guess our code. We then compare the code to the real code, and then we tell them, we check first if they actually guessed the code. If they did guess the code, and we can determine that by seeing if their correct position is equal to code length, we tell them they guessed it in this number of attempts, and then we break out of this for loop. Otherwise, we tell them the number of correct positions and incorrect positions they had in their guess. If we get to this else statement here, what that means is we never broke out of this for loop, which means the user never guessed the code and the for loop ended. So they ran out of tries. We tell them you ran out of tries, and then we tell them what the code was. Pretty straightforward. That is game. We have check code. We already ran through that. Guess code and generate code, and then all of our constants at the top of the program. And you can see kind of how this program is well laid out. It's very easy to understand what's going on. All right, so now let's run our code and see if this works. Okay, so I'm going to run it here. We have welcome to Mastermind. You have 10. This should say tries to guess the code. The valid colors are the following. I always like to start with just one color. Okay, so correct position 1, incorrect position 0. Okay, now let's try this. Correct position's 2. Okay, that tells me the Y is in the correct position. Or sorry, not the Y, the R. So I'm going to go R, Y, W, W. Okay, so now I know my Y is somewhere else. So I'm going to go R. Let's go blue, Y, W. 2 correct positions. Okay, let's go R, O, Y, O. And we guessed it. Okay, nice. Got the code. That was actually pretty lucky there that we guessed that on try 5. Now, of course, we could run the code multiple times, test out all of the different cases. But I think for now, that's it. And our code is working. So with that said, guys, I think I'm going to wrap up the video here. I hope that this was helpful. I'll zoom out a bit just so you can kind of read most of the code. I can kind of slowly scroll through it in case you want to pause and see where maybe you made a mistake. If you guys like these kind of short, quick Python projects, let me know in the comments down below, and I am happy to make more. With that said, I'll wrap it up here. Hope you guys enjoyed. If you did, make sure to leave a like, subscribe to the channel, and I will see you in the next one.